Hello everyone, this is Dr. Lennon, and I am going to walk you through a sample collection of some dosage problems, and we're going to be using the dimensional analysis method to get the answers to these. So, these problems kind of range in difficulty and number of steps, but the main thing we're looking for is to just focus on the units. So a lot of people like to go through problems, especially nursing style problems, and they read them and go through a bunch of concepts. And these problems work a little bit differently. Really, we're just looking for units. So these problems are set up where kind of they ask for the unit at the very end. Usually, if they're set up a little bit differently where they ask what's ordered and what's on hand, this would be known as the thing that's on hand. So here we're trying to first find, if you look at the last sentence, it says we're looking for tablets for a dose. So I write down that unit, tabs, and I know once I can get to that unit, then my problem's done. So then what I do is I just look somewhere else in the problem for the word tablets, and I look at anything else that goes with it. So here we have that the medication is available in 75 milligram tablets. So that means for every one tablet, there are 75 milligrams of whatever medication we're talking about. So I write 1 tab over 75 mg. Okay, so I need tablets to be on top. So the first thing I'm looking for is this tablets, and because it's the only thing, it needs to be on the top of my fraction. So then what I need to do is I just need to be able to cancel out this milligrams, and if I can do that, then tablets will be the only unit left. So I look for milligrams in the problem, and I have it, and I have 300 milligrams. So what that means is that there are 300 milligrams over the one dose. So there are placeholders that we put in dimensional analysis, and the 2 times that those come up is they come up whenever there's a ordered dose or whenever there's a patient weight. So that's just a number that has no accompanying unit. So my unit of milligrams crosses off, and then I just multiply the numbers, 300 over 75. And again, I always look if there's any rounding restrictions, I'm going to do that, but there are not here, so I get my answer of 4 tablets. And so I've done that problem. That was a very easy one-step problem, but that's the setup that you go into in general. You identify the unit that you want to finish with, and then you try to find that in the problem, and then go ahead and cancel any other units. That's the goal. So let's go ahead and go to the next problem. They'll get a little more challenging as we go on. So problem number 2, again, same strategy. Don't start reading the problem, just look at the end. The nurse should prepare to administer how many milliliters? So my answer here needs to be in milliliters. That needs to be the unit of my final answer. So I look in the problem. Do I see milliliters? Well, I see it right here. 2 milligrams in 1 milliliter. So milliliters has to go on top because that's what I'm trying to finish with. So I have my 1 milliliter over my 2 milligrams. And so now I want to look in the problem for milligrams. I don't see milligrams anywhere, but there are 2 other units in the, I would call the gram family that we commonly run into, and those are grams or micrograms. So I do see one of those units in my problem, 225 micrograms, which is the dose. So we know at some point that we'll get a 1 as a placeholder, but I don't want to use that right away. Instead, I want to use my conversion factor from milligrams to micrograms. So I'm going to use that conversion factor, and first what I want to do is I know milligrams need to get canceled, so the only way units are canceled is if they're on the opposite part of the fraction. That means if milligrams is on bottom and my next fraction has it on top, they cancel. But if they were on the same part, they would not cancel. Then I need to fill in the numbers. Well, again, micrograms are smaller than milligrams, so I know there are 1,000 micrograms for every 1 milligram. Okay, and now the milligrams cancel out, and the units I'm left with are milliliters and micrograms. Now I can use this ordered dosage of 225 micrograms. So I multiply by 225 micrograms over the placeholder of 1. And then again, I just multiply across 225 over, multiply all the numbers on the bottom, 2 times 1,000 times 1, 2,000. Then I put that in the calculator, and it says round to the nearest hundredth, so that's 2 decimal places. So 225 divided by 2,000 comes out to 0.1125. So hundredth is rounding to the second decimal place, which means I need to look at the third decimal place to tell me what to do. If it's a 0 through 4, I keep that second decimal place, which is a 1, the same. If it were a 5 through 9, I would have bumped it up by 1. So in this case, I get 0.11 milliliters. And let me just remind you, so that's our final answer for this problem. But in terms of those milligram, microgram, and gram conversion factors, we know that, so I think of it as kind of like big, smaller, smallest. A gram is the biggest, so 1 gram is the same thing as 1,000 milligrams, and then 1 milligram would be the same as 1,000 micrograms. So those are the conversion factors that we need to remember whenever we have to convert using either grams, milligrams, or micrograms to go between those. All right, let's move on to problem number 3. So for this one, again, I'm not reading the problem. I'm just looking for the last sentence. How many milliliters? So I know my problem needs to be milliliters. So I go into the problem. Okay, here we see milliliters in one part and there's a slash. Well, a slash is just treating it like a fraction. So the 5 is the number that goes with mg, and since there's no number with ml, we're just going to treat it like a 1. So I need the mLs to go on top, so I have 1 milliliter over the 5 milligrams, and then I need to look for either milligrams or something in the gram family. There's only one number here, and it's milligrams. That's the dose, so this problem I am already done. We get the placeholder there, cancel off, multiply across. 1 times 7.5 is 7.5. On the bottom, we get a 5, so our answer here is 1.5. That's all the decimal places it has, so we're already rounded, and our answer is in milliliters. So we're all done there. Okay, so that was pretty easy. First 3, pretty straightforward, no more than 2 steps. As we get to problem number 4, things start to get a little bit more interesting. So in this problem, it says, how many units of insulin will they receive each hour? So our units for this problem are units per hour. So that's what we're trying to finish with, units per hour. Okay, so this one we have to be a little bit careful because as we scan for units in the rest of the problem, we see it appearing in 2 places. We see this 125 units of insulin and 250 milliliters, and we also see this 0.1 units per kilogram per hour. So which one do we use? So that's something you might want to think about. Pause the video, say, okay, well, which one would I pick? It's, you know, I see people choose either one quite frequently. So try and give yourself a chance to think about that. But which one does it turn out to be? Well, let me go ahead and erase these 2. So the one it actually turns out to be, and my rule of thumb, whenever you have this thing appearing in 2 places, usually there's going to be some extra information in the problem. And the one that we use is the 0.1 units per kilogram per hour. And often I'll see students want to use the other problem, I think because it looks a little simpler or the numbers seem nicer, but that's actually just the concentration of the insulin in the bag. So we don't really use that number. What's my rule of thumb for knowing which one to pick? Well, I want to use this one, this 0.1 units per kilogram per hour, because the units I'm trying to finish with are units per hour. So this 0.1, it matches 2 out of the 3 things. So the other one only matches units, 125 units over the 250 ml, but the 0.1 has both units and hours, so I'm going to use that one. So how do I write this when I have 3 units written like that? Well, this is the way you should always write it. You should write 0.1 and then write the first unit on top. So we have 0.1 units, and then on the bottom, we want to write both the kilograms and the hours. So we treat those 2 kilograms and hours on the bottom and units on the top. So we have units and hours matching. So that's all we really need to do in this problem is cancel that kilograms. And with kilograms, again, there's two ways that we measure patient weights. We have both kilograms and pounds, and the unit conversion you need to keep in mind there is that 2.2 pounds are the same thing as 1 kilogram. So let's first use our unit to cancel out that kilogram so that we can then use the pounds. So we need to put 1 kilogram on top so that it cancels with the kilogram in the bottom in our first fraction, and then we put the 2.2 pounds on the bottom, and then we have one more fraction to multiply by. That's where we go ahead and use the patient weight of 131 pounds. And remember, 131 pounds is a patient weight, and patient weights typically have placeholders in their fractions. So we get 131 over 1. So the kilograms have canceled, and now the pounds have canceled, and the only remaining units in the problem are units over hours. So that's how we know that's how we know that we're finished. We've matched the units that we're intending to get to. So if you multiply on crossed on top, you get 13.1. On the bottom, you have 2.2. We're trying to round to the nearest whole number. So when we round to the nearest whole number, well, let's see, 13.1 divided by 2.2 is 5 points. Nearest whole number, so it's 5.95. So when we round it, 9 is where we're looking, so we need to bump the 5 up to a 6. So we get 6 units per hour as our answer. All right, so that was our first tricky one. Let's go ahead into number 5. So again, read the last sentence. How many milliliters should the nurse administer? So we have milliliters equals. Find milliliters in the problem. Again, we have a ratio. 5,000 goes with the units, and the milliliters, we can put a 1 next to it. So we want the milliliters to be on top, so we would have 1 milliliter over 5,000 units. And then now our job is to cancel units. So how can we cancel units? Well, we've got the only other place units appears in the problem is right here, 60 units per 1 kilogram. So we get 60 units over 1 kilogram. So now units are gone, and we need to cancel kilograms. Typically, that's going to be with a patient weight, which we see in the very first sentence. A patient weight of 95 kilograms. Patient weights get placeholders, so 95 kilograms on top, 1 on the bottom, so the kilograms cancel, and we multiply across. 1 times 60 times 95 is 5,700 on top, and on the bottom, multiplying across, we just get 5,000. They want us to round to the nearest tenth, which is 1 decimal place, so we need to look at least 2 decimal places to determine how we're rounding. So we get 1.14. So 4 does not round up the tenth, so we just leave our answer as 1.1 milliliters. So that is the answer to problem number 5. Okay, let's continue. So number 6, we're finally looking at a ratio of units. So we have milliliters per hour. This is known as a flow rate. It determines the volume of the IV that's being given each hour. So that's what we want to finish with here, milliliters per hour. And we need to look for milliliters in the problem. So that only appears one place. Again, we have this slash, so we're going to treat this as a fraction. We know the milliliters needs to go on top, so we're going to write this as 500 milliliters over 800 milligrams. Now our job is to cancel milligrams. So don't think about the hours until this milligrams is gone. So do we see milligrams anywhere? No, we only see this complicated looking unit, micrograms per kilogram per minute. So again, we need to remember how to set this up. Well, we want to cancel milligrams, and we know a milligram to microgram conversion factor. So remember, again, grams are biggest, milligrams are smaller, and micrograms are smallest in our 3 typical mass measurements that we have for these medications. So we know in 1 milligram there are 1,000 micrograms. and then milligrams are gone. So now we can use this number from the problem I've underlined in the first sentence. And there's 3 units, so remember we're going to put micrograms on top and then the kilograms and minutes in the bottom. So we've got 7 micrograms over kilograms per minute. So the micrograms are gone. So now, so at this point, there's kind of 2 things we can do. We need to cancel the kilograms, and we also need to change our minutes to hours. So you can kind of do that in either order. It doesn't really matter. I don't have a preference myself. I would probably change minutes to hours first. So again, minutes needs to be on top and hours on bottom. So the minutes are gone. Again, there's 60 minutes in 1 hour. So now the only job left, we have milliliters on top as our only unit, kilograms and hours on the bottom. So we need to cancel kilogram. So we're looking for a patient weight, and we have that patient weight. The client weighs 86 kilograms. So 86 kilograms over the placeholder of 1. So the kilograms are now gone, and we can multiply on top. 500 times 1 times 7 times 60 times 86. Again, the more steps in the problem, we should expect to see larger numbers. So don't panic if the numbers seem big to you. We don't want to think about if it's reasonable until we get our final calculation there. Again, it's always a good idea to make sure you're counting your zeros properly. I've seen people mess this up all the time by not making sure that they're counting their zeros correctly from the calculator. So if you multiply on top, you get 18,060,000, and on bottom you get 800,000. So when you divide those, what do we get for our answer? We get 225.75, and they want us to round to the nearest tenth. So the 5 at the very end of this decimal is going to bump the 7 up to an 8. So our answer will be 225.8 milliliters per hour. And that's that. So that problem had, 5 fractions in it. So we had to, again, just follow the units. Look for the unit, try and cancel the ones in the bottom. Once you're done with that, then start paying attention to the other things. But again, we're only focusing on the units. We're not really reading too much into other things. Okay, problem number 7. We've got what's known as a drop rate. So GTT means drops, so we're looking for drops per minute. So this drop rate is, again, related to the flow rate, which is the volume. And so we're not going to get into this yet, but this IV tubing, 10 GT per milliliter, that's known as the drop factor. Different size tubings have different size droplets. So bigger tubes would have bigger drops, so they would be fewer drops to a milliliter. So this would be known as macro tubing. 10 drops per milliliter would be pretty big. Micro tubing would be smaller tubes, and it would take more drops to make up a milliliter, maybe something like 60 drops per milliliter. So sometimes you'll see those terms referred to in the literature. All right, so back to the strategy. We're just looking for drops per minute, so GTT per minute. So we first look for the top of the fraction, that unit, drops per minute. So the only place drops appears is in that drop factor. So we write down 10 GTT per milliliter. So now our job is to cancel this milliliter in the bottom. So we see milliliter appear in one place, 75 milliliters per hour. So we have 75 ml over the 1 hour. So now our milliliters are gone, and we're left with drops and hours. So to finish the problem, that's all we need to do is change hours to minutes. So we need hours to go on top to cancel, and minutes to go on bottom, which is the unit we want to finish with. So in 1 hour, there's 60 minutes. Again, we can just multiply across. So we get 750 on top and 60 on the bottom. So 750 divided by 60 is 12.5. They want us to round to the nearest whole number, so the 5 will bump that up to 13 drops per minute. All right, so that's it for problem 7. 3 more to go. 8 and 9, I think, on this are the most difficult, or at least the longest. So in this one, we're trying to figure out how much medication in milligrams is given each minute. So mg per minute are the units we want to finish with. So look for milligrams. We don't see milligrams anywhere in the problem, so we're looking for grams or micrograms. So we see 1 gram per 250 milliliters. Now, I don't want to use that yet. Again, I want to start with the conversion factor to make sure the milligrams are in the appropriate place. That's just a better habit. So if we have milligrams here and grams here, I know that there are 1,000 milligrams in 1 gram. So then I can use the number in the problem. So I want to cancel grams. So I'm going to put the 1 gram on top and the 250 milliliters on the bottom. So now what happened, the grams are gone and I have the milligrams on top the way I wanted to. So now my job is to cancel this milliliter. So I'm going to look for milliliters in the problem. I see it in the second line at 19 milliliters per hour. So I write a 19 ml on top, and on the bottom I write 1 hour. So the milliliters are crossed off. And again, I'm left with milligrams and hours. So the last thing I want to do is change hours to minutes. So 1 hour on top, 60 minutes on bottom. And then I multiply across on top, so I get 19,000 on top. And 250 times 60 gives me 15,000 on the bottom. So what does this leave me with? Well, it leaves me with 1.26. And I want to round to the nearest tenth, so this comes out to 1.3 when I round milligrams per minute. All right, so that's it for number 8. Not so bad, really. But here comes number 9. This is the doozy. This is the longest one. So what we're actually looking for now is we're looking for one of these triple ratio kind of deals. So we've got 3 units involved. So remember how we write that. We write micrograms on top, and then we write the other 2 on the bottom. Kilograms per minute. And so our job is to look for micrograms in the problem. We don't see it, but we see milligrams. So we're going to start with that conversion factor, micrograms to milligram. We know there are 1,000 micrograms over the 1 milligram. So we start with our conversion factor so that we know micrograms is in the correct part of the fraction before we use the 50 milligrams in the 250 milliliters. So now we can use that number, that ratio. So we have the 50 milligrams on top, so the milligrams cancel. 250 ml on bottom, so the milligrams are gone. Now I want to cancel milliliters. So I've got 75 milliliters per hour. So 75 ml goes on top, 1 hour goes on the bottom. Okay, so I know I want minutes on the bottom instead of hours, so I can change my hours to minutes. So 1 hour is the same as 60 minutes. So the hours cross off. And now this is where most people get stuck on the problem. We've got micrograms on top and minutes on the bottom. So the only thing missing is how do we get the kilograms involved? We don't have that anywhere in the problem. Well, we know it's going to involve a patient weight. So we see this patient weight up here and it's in pounds. Now we don't want to use the patient weight yet, but we know it's pounds and we want kilograms. So let's go ahead and use that conversion factor, 2.2 pounds to 1 kilogram. Now we want to finish with kilograms on the bottom. So for our conversion factor, the kg should go on bottom and the pounds should go on top. So the 2.2 goes next to the pounds and the 1 goes next to the kilogram. So now what's our job? Well, kilograms is where it's supposed to be. So what we need to do is we need to cancel pounds. And I think this is what throws a lot of people off because the units only cancel if they're on the opposite part of the fraction. So that means pounds need to go on the bottom. So we have that 163 pounds that the patient weighs. And in this case, the placeholder actually goes on top. So patient weights get placeholders, but I think the thing that trips a number of students up is they want to put the placeholder on the bottom because they usually see it there. But really what we should pay attention to first is, are the units canceling that need to cancel? And if they do, just put the placeholder where it belongs. So the pounds cancel, so the placeholder goes on top. And if you figure that out, now we've got, if you circle the units that are left, we've got micrograms on top, we've got minutes on bottom, and we've got kilograms on bottom. So we know that we have matched exactly the original units. So then we want to multiply across. So 1,000 times 50 times 75 times 2.2. So on top we get 825 and 4 zeros. So that's what? 8,250,000. And on bottom, if we multiply all the way across, so 1 times 250 times 1 times 60 times 163, we get 2, 4, 4, 5, and 3 zeros. So that's 2,445,000. And then plug that into the old calculator to figure out what's going on. So round to the nearest whole number. Well, I'm getting 3.37, so this just comes out to 3. And then our units are micrograms per kilogram per minute. Okay, so I hope you followed me on that one. The steps work the same as usual. The two tricky bits, I think, are how do we get kilograms involved? So use the conversion factor first, and then make sure you're canceling pounds so the placeholder, in fact, goes on top. Okay, so the last one is a safe dose problem. It's really not that difficult. So when they talk safe dose, there's a range. There's kind of like a minimum dose and a maximum dose, and you're just making sure essentially that whatever ordered is falling between those. So it says, what's the maximum safe dose? So here it's given milligrams per kilogram of body weight. So for the max safe dose, we're just going to use the bigger number. If it said something about a minimum safe dose, we'd use the smaller one. So our answer is just milligrams. And basically, we're going to use that bigger number, 0.08 milligrams per kilogram. And then that's all we need to do from there is multiply by the patient weight, which gets a placeholder. So that's 94.3 kilograms over the placeholder of 1. And this will give me the max safe dose. So just multiply those two numbers. And we get 7.54. So that rounds nearest tenth is what they ask for. So that's 7.5 milligrams is our maximum safe dose. Okay, so that's the main strategy. Again, remember your how to use your conversion factors. The main goal, never read the problem. Always start with the unit that they're asking for. Find it in the problem. Go ahead and cancel whatever's left over. And once you've matched the units that they're asking for, you know the problem's over. The only other thing, what gets placeholders, typically ordered doses get placeholders, also patient weights. So that's just a unit of 1 in the opposite part of the fraction that doesn't have an associated measurement unit. Okay, so I'll probably do 1 or 2 more of these, and I will make sure to include a PDF with a blank set of problems. So you want to go ahead and practice those, and if you find yourself stuck, come back to the video, watch it again, and see if you can get your issues sorted out. So this is Dr. Lennon. Thank you for watching.